Hello class, today we're going to talk about trigonometric functions in radian modes. So throughout this lesson, you're going to learn how to convert all your trigonometric function concepts and now applying them when they are in radian mode. So let's go back to the unit circle. And we have understood the unit circle in degrees in the past, which would say 0 degrees is here, 90 is over here, 180, 270, and 360 for a full rotation. And remember that we're doing positive degrees when we go counterclockwise and then negative degrees when we go counterclockwise. But we're going to now transfer that understanding into radian measure. So if we remember that a full rotation around a circle in radian measure is 2 pi, and now we're going to divide that into 8 pieces like what we drawn out here. So 1, 2, 3, 4, 5, 6, 7, 8. So if we're going to divide the whole circle of 2 pi into 8, we would get exactly pi over 4. That means that each of these 8 sections, so this first angle here to reach there would be 1 pi over 4. To get over here will be 2 pi over 4, but that simplifies to just pi over 2. And the next one would be 3 pi over 4. And then we get to 4 pi over 4, which is exactly just pi. And then 5 pi over 4, 6 pi over 4, which reduces down to 3 pi over 2. And then we get 7 pi over 4, and this would be 8 pi over 4, which is simply 2 pi, which is what we want. So now in this unit circle, when we turn it into 8 pieces, we get, instead of the 45 degree that we think of, it's now pi over 4, 90 is pi over 2, 135 is now 3 pi over 4, and so forth, okay? But then we have more angles that we need to think about, more common ones, and we're going to now divide our unit circle into 12 pieces. So if we go through the similar procedure of dividing 2 pi, a full rotation, into 12 slices, you have equal to pi over 6. So that means that the first angle, which was used to be 30 degrees here, is now pi over 6. And then the 60 degrees that would have been here is now 2 pi over 6, which is equivalent to pi over 3. Right? We still have our 0, and this is now at 3 pi over 6, which is pi over 2, which is similar to what we had above, right? Which we hope is the same since it still represents our 9 degrees. And then over here would be 4 pi over 6, which is 2 pi over 3. Then we have 5 pi over 6, 6 pi over 6, which is just pi again, which is our 180. And then we have 7 pi over 6, 8 pi over 6, which is just 4 pi over 3. We have 9 pi over 6, which is our 3 pi over 2 again. This one would be 10 pi over 6, which reduces to 5 pi over 3. And then we have 11 pi over 6. And of course, 12 pi over 6, which is 2 pi. Okay, so it's good to get familiar. You don't want to memorize them, but you need to have a basic understanding of where all these different radian measure angles are in the different quadrants of the unit circle. So which are the ones that you need to know? So as you can see, these are all increments of pi over 6 or pi over 4 or pi over 3. And you just kind of need to know the multiples or the relatives of all these across the whole unit circle. What else do we need to transfer into radian measure is our special triangles. Our special triangles, when we were talking about them in degrees, would have been in 45, 45 and 50, 90, This one would have been 30 degrees, and this one would be 60 degrees. And there's 90. So now we have to turn them into radian measure. So in a 45-45 triangle here, you would have had the side lengths of 1, 1, root 2. Well, now in radian measure, instead of 45, that was pi over 4. So pi over 4, pi over 4. When we talk about sine, cosine, tan, we'll use these side length ratios. And now to transfer the 30-60 triangle, we would now convert this into pi over 6. And this one was pi over 3. And so they're kind of opposite numbers. We see a 3, we want to think of pi over 6. We see a 6, we want to think of pi over 3. And the side lengths are 1, 2, root 3. Okay, and so now we've got our pi over 6 is on the same side, adjacent side is pi over 3. Okay, which was before 30 degrees. So you kind of need to know these when we talk about exact values. So we need to know and kind of have a good understanding of how to convert those special triangles for sine, cos, and tan. And we have to remember that sine, cos, and tan deal with different, sine is dealing with opposite over hypotenuse, cos would have been adjacent over hypotenuse, and tan would have been opposite over adjacent. And so if we go through all the special triangles, the ratios would look like this. So it kind of looks like this. However, we have to make note of a few special ratios that we have to kind of transfer. So we see here this 1 over root 3. That happens when we're taking the 10 of pi over 6. So here's pi over 6, and when we take the 10, so the opposite, which is 1, over the adjacent, which is root 3. That's what it would look like, except we don't like when radicals are in the denominator. So we're going to transfer that into a different format. We're not changing the ratio, we're just changing the way it looks. So in order to get rid of the radical on the bottom, we're going to multiply the fraction by the radical, both top and bottom. By doing this, we're just basically multiplying by 1, because root 3 over 3 is 1. So we're not changing the ratio, but we're just changing the way it's going to look, because what happens is that by multiplying the root 3 by root 3, it's like saying root 3 squared, because root 3 times root 3 is root 3 squared. And that essentially cancels out the radical and just becomes 3. So we now have the denominator of just 3. But we can't just change the bottom, so we had to multiply the top as well by root 3, and that just becomes 1 times root 3, which is just root 3. So in the end, we want this ratio to be root 3 over 3. And so you want to not just memorize that it's 1 over root 3 based on looking at this, but you have to make sure you transfer it to its proper format, which would be root 3 over 3. And we would be doing the same with this one. So 1 over root 2 ends up becoming root 2 over 2. So that is on both of these here, because we're doing with pi over 4, which would be opposite or adjacent over hypotenuse. And that's it. So make sure that when these 3 special side lengths, when you write them down, you need to transfer them into the proper format. Okay. All right, so now let's actually apply this understanding of radicals into our special triangles and answer similar questions to what we've done in the past. So, for example, determine which quadrant does each of the following angles terminate in standard position. Remember that standard positioning is when the initial arm starts over at 0 degrees and then it rotates counterclockwise until it reaches the angle of interest. So in this case, we're talking about 5 pi over 4 is our angle. And so the terminal arm will end up being here. How do I know that? Well, remember, we know this is 0. Up here is 2 pi over 4, which is pi over 2. And over here would have been 4 pi over 4 because that ends up being pi. So 5 pi over 4 will now be in the third quadrant. Okay, because it's ending over here. Oops. So it's good to know kind of this type of question helps you kind of figure out where the different angles are in radian measure. I'm not going to do all these questions. You can find them in the OneNote answered when we did them in class. I'm just going to do a few key ones just so that you know how to handle different situations. Let's think about question number D here. So with question D, we see that 7 pi over 4. Well, I do know that if I had 8 pi over 4, I would be at 2 pi, which is pretty close to 7 pi over 4, but just shy. So therefore, I am just shy of 2 pi, so my terminal arm is here, and there's my angle. So that means I am now in quadrant 4 for this question here. And then we're going to look at one more question here, which is 3 pi over 2. And in this case, well, this kind of sounds familiar because here is 0, here is 2 pi over 4, which end up being pi over 2. And then we had 4 pi over 4, which is pi over here. And here we have 6 pi over 4, which would have been 3 pi over 2 simplified, which is the angle we're talking about. So therefore, this means that the terminal arm is actually right down here. So then you might ask yourself, what quadrant are we in? We aren't in a quadrant. We're actually in the boundary of 2 quadrants. And so this is called a boundary angle, where it is just simply on the y-axis and not in any of the quadrants. Okay? So let's move on to a different set of questions. So you can also remember these types of questions where we're asked to find the exact value of different sinusoidal functions. So when we see the word exact value, I want you to always remember exact value means we're going to be using those special triangles and the cast rules. Okay? So that's what it means when we talk about exact value. So you need to remember these two properties. First, we're going to continue what we did last time, where we need to know where is 3 pi over 4. That's going to help us with the question. And so you must always draw a diagram to show where it is. Well, 3 pi over 4 is almost at a full pi, because it's shy of 4 pi over 4, so we're somewhere here. That means our angle, theta, is at 3 pi over 4 is represented by this arrow here. But when we're talking about an angle greater than 90 degrees, or pi over 2, we're going to talk about the relative special angle here. And so we need to find the relative special angle, which is left is the angle inside this triangle. So this one would be pi over 4. And so our side lengths would be 1 root 2. And so when we think about cos of 3 pi over 4, we would see that it's talking about our x over r, which in this case would be 1 over root 2. But remember, we don't write radicals in the denominator, so we have to transform it into root 2 over 2. And then we have to remember our cast rule. In this quadrant, the sign is positive, so if we're talking about cos, we know the answer must be negative. And so our answer for cos of 3 pi over 4 would be equal to negative root 2 over 2. And so you would do something similar for the other ones. I just want to do one more example just to make sure we understand it before we move on. Here, we're going to go down to cos of pi over 2. Well, pi over 2, if you recall in the diagram, is actually just above here. It is our 90-degree angle. So our theta is being represented by there. So our terminal arm is right on the axis. It's a boundary angle, do you remember? So if this is a boundary angle, how do I get the ratio? Well, when we talk about cos, we're always talking about x over r. And in this case, our x value would be 0. Our r value, because it's a unit circle, would have been 1, but 0 divided by 1 is still 0. So the answer of cos pi over 2 just ends up being 0. This lesson is going to take longer than 15 minutes, so I'm just going to, instead of rushing through the last part, I'm going to make a second video. So just watch out for that one, okay? Good luck.